Hello, MCT4C. We're in Polynomial Functions, Day 3. We'll be very thankful that today's lesson is very short because our focus that will work very well for this particular lesson is for you to work in groups of your peers. So tomorrow we'll be working on 2.2.2, which has 4 parts. We'll just do a little bit tonight to get you warmed up. We looked yesterday at linear and quadratic functions that are very familiar to you. We're going to add to the pile cubic and quartic functions. So with your graphing calculator, you'll be looking at a series of all 4 of those types of functions. We want to look especially at x-intercepts for each, the degree of each, and the behavior, and just verifying that they are in fact functions. So I would like to just do 2 with you so you're ready to go for tomorrow. So this comes straight from 2.2.2. You can cheat and grab what we'll talk about tonight and put it on your paperwork tomorrow. One function I'd like to look at is y equals x cubed minus 2x squared. The first thing they're going to ask you for is the leading coefficient. So we're looking for a number that would be in front of the highest degree. So we are looking for a number there. There isn't one, so it's invisible. So our leading coefficient for this function would be a 1. The degree of this function, since its highest degree is x cubed, would be 3. We're going to use our graphing calculators to draw a sketch. So I'm going to use the document camera and we're going to type in y equals x cubed minus 2x squared. Okay, so I have my graphing calculator turned on. I want to type in the function y equals x cubed minus 2x squared. So I have my function button. We want x, our only variable choice is that guy. We want x cubed, so x to the power of, so I need him. There's x cubed. Minus. Remember, it is a minus. I'm going to have to scoot this up to show you. It's subtract right there, not the negative button at the bottom. So subtract 2x squared, 2x squared. And that should give us a rough graph. There we are. So we're going to draw that sketch. Let's see if we can move this over. Yep. So we want to sketch a rough one that matches what we see on the graphing calculator. So it approaches up to 0, does a dip-de-doo, and then there. Okay, it would be nice if we marked that it looks like the x-intercept might be 2. And we know that there's an x-intercept at 0 here, so you've kind of got a rough sketch of what you see on the graphing calculator. Okay. The number of x-intercepts. It appears to our eyes that there is an x-intercept here and an x-intercept here. So it appears that there are 2. The end behavior as x gets really, really big. So as we're going this direction forever and ever, it looks like our function also is going to get bigger and bigger and bigger in the upwards direction. So from what we've seen of our function, as x gets really huge, y is also going to get really huge. If we look in the left side, as x approaches negative infinity, so as x gets really, really large in a negative sense, the function is going to go that way. So y is going to approach negative infinity. Is this a function? Yes, it is. We can use a vertical line test. To verify that it is a function. I draw any vertical line it will touch that function in one place. Second function I would like to look at is y equals x to the fourth minus 5x squared plus 4. We're going to look at the same things. We want to know leading coefficient, is also invisible. It is also a 1. The degree of this function is 4. The end behavior and the x-intercepts. We are going to look at a sketch to determine those. So let's put on our document camera. Let's clear the last one. We are going to put y equals x to the power of 4, subtract 5x squared plus 4. Good. We can see it nice and clear. We don't have to change our windows. So for our sketch, we want to indicate that this appears to cross the y line where y is 4. It appears to have two x-intercepts. It looks like at 1 and 2. And our w on the left appears to have two x-intercepts as well at -1 and -2. So roughly our sketch is like that. How many x-intercepts do we have? It appears that we have 4. It would be nice if you could list them. Trusting our eyes, it appears we have an x-intercept of 1, and of 2, of -1, and of -2. And the end behavior as x gets really large going this direction, it appears that the function gets really large in an upward direction. So it appears that as x approaches infinity, y approaches positive infinity as well. On the left side, as x approaches negative infinity, our function gets really big in a positive direction. So in both directions, as x approaches infinity to the left and to the right, the function approaches positive infinity. So in class tomorrow, you're going to continue with your friends to fill out all of 2.2.2 and a true or false page 2.3.1.